To start modeling the MEP items, when we first open Revit, we will click on New so that we can select a certain template file and start modeling based on that template. So we will start off by talking about the ribbons or the tabs. We have some tabs up here: File, Architecture, Structure, and so on and so forth to the end. Now, if I click on each of these tabs, we will see a set of options which is also called ribbon. All of the tools that are related to each tab will be shown in its ribbon. For example, I'm going to click on Architecture, which is actually the tools that are required for drawing mechanical items. When I do that, I can see the tools for drawing mechanical items. For example, you see wall, door, window, and other items. Now, when we click on Structure, I will be able to see the tools that are needed for drawing the structural items. Things like beam, column, or the truss, and some other items. We also have another tab which includes all of the facility items, both mechanical and electrical, and they all go into systems. If you recall, previously we have said that the template which includes these settings for the mechanicals and the electricals is called systems. So Revit recognizes systems as both the mechanical and the electrical items. In the ribbon section, all of the tools have been grouped. For example, as you can see right here, I have this HVAC group. You can see the name of it down here, and they've been separated by this line. You can see HVAC, mechanical, plumbing and piping, or for example this one, electrical. These are all called panels. So I can say that the Systems tab and the HVAC panel and the duct command or tool. This is how we can say to address some things. We also have some other panels as well, and we will become familiar with them in order as we go further in the modeling. Down here we have a bar, which by default looks green if nothing has been selected. So if I select a tool or actually a command, for example in the Systems tab, I'm going to click on the duct command, and then we can see that its color changes from gray to green. And not only that, but also some new items have been added to it. So we call this bar the Options bar, and depending on which command I am selecting, the options and items in here will be changed. There goes the duct command. For example, I'm going to go to the Systems tab and click on Pipes, for example. As you can see, the options changed. For example, we see the diameter here. Or we could go to the Systems tab again and click on Cable Tray command, and then we will see the width and height of the cable tray. So depending on which tool or command I will be selecting, the options and items of this bar will be changed so that we could use and change during the drawing. To cancel each command that has been activated, I could just press the Escape key on keyboard. As soon as I press the Escape key, as you just saw, the command has been canceled and the bar went back to gray. So there goes one thing. We also have a tab called Modify. As you can see, this one is called Modify, and as soon as I click on it, some new tools will be shown here for me up to the Create panel. So depending on which tool or command you will be selecting and using, the name of this tab will be changed. For example, I'm going to click on the Duct shortcut, and we will also be talking about the shortcuts later on. And then we will see that besides the Create panel, a new panel will be added called Placement Tools, which are some tools that are needed to draw the duct. So as you can see, the default Modify name has been changed to Modify Place Duct. So this tab specifically is considered a contextual tab. Let's go check it out and look it up. To know the definition of the contextual word, it's best that we consider this one. So as you can see, it's an item that depends or relates to the circumstances that form the setting. So the tab was named Modify by default, but depending on the circumstances or the tools that I select, it will be renamed. So it only changed to Modify Place Duct. If I select the Pipe command, it will be changed to Modify Place Pipe. Or if I select the Wall command, it changes to Modify Place Wall. So don't forget that not only the name, but also the tools will be changed. So this tab changes according to which command I am selecting, and it will be giving me the needed tools. As we go further in the modeling process, we will become more familiar with this whole tab. We also have two new windows. Actually, let me drag this wider so you can see. The one that is on the left is called Properties, and as for the window that we see here on the right, this one is called Project Browser. If you open and use Revit for the first time, it is possible that you may see these two windows like this. You will see two windows above and below each other. These two windows are actually very practical for us, and we really need them, and they have to be available for us. Actually, I can change the placements and locations of these two windows. As you just saw, I will click on the name of this window, and while I'm holding the left click, I will drag it around, and then I will put it somewhere empty. So it just got out of that one. Now I'm gonna hold it again and drag it to the hard right. Once I see the blue box, I will release it. And as you can see, it will go to the right side of the entire software. So I can just select it and drag it around wherever I want. For example, I'm going to put it up here. As you can see, when the cursor goes to the edge of this screen, this box will appear and then I can release it. Or I can drag it and put it beside this Properties window. Or I could just put it above or below the other, as we saw in the first place. So depending on how wide your monitor screen is, and also the way that you are working on your project, you can change the place of these windows as you want. So I'm going to put the Project Browser window on the right and the Properties window on the left. Now, it is possible that someone may misplace this and doesn't stick it to the software. And they might think that it's right, but it's not. This one is actually just floating around here. So we might draw something and then it goes underneath this one and we won't see it. Actually, let me do it for you real quick. I'm going to draw a duct. We will talk about how to draw ducts later on. So it just went under this window. I can't see it. It seems as if nothing has been drawn under there. But if I place this window correctly and drag it to the hard right, and then release it once I see the blue box, and then we will see this whole full screen right here. It is also called the drawing area. So the drawing area becomes completely separate from the Project Browser window. So now what are these two windows? The Properties window actually shows some properties. So when no command or tool has been selected, I will only see the properties of the view that is open. For example, its scale or any other details related to that, and some other items as well. As soon as I select and activate a command, for example, in the Systems tab, I will select the duct. I will see the properties and settings related to the duct right here in this window. So depending on which command or tool I will select, all of the properties right here will also be changed. Here's a tip. When you select an object, you can change the properties and settings of it and control it from 3 different places. One of them is from the Modify tab, the other is the Options bar, and the other is from the Properties window. I'm going to press on the Escape key so that it would all be cancelled. The Project Browser window consists of many different items. Let me click on this minus so that the views will be closed. We have some different items right here in this window with which we will become more familiar as we go further. The most important one is the views. So I can choose which floor I want to view and see, whether I want to see the plans, or the ceiling plan itself, or the section, or the 3D or elevation. I can select and see all of these views from right here. So, depending on which template we have loaded, it is possible that these views would go into different groups and categories. Now, in this mechanical template which we have loaded, we have the main mechanical category, and we also have the main plumbing category. First, let me close them so you could see. Mechanical and plumbing. When we open the mechanical group, we can see the HVAC, and when we open the plumbing group, we will see plumbing. And as for the subgroups of all of these, we will have the views available. So in this template, the views that are the subgroups for the mechanical and HVAC, or actually these items, we can see the canals and the heating or cooling pipes. This is how they've been set up. And the items that are the subgroups for plumbing, we will see the drain, vent, and irrigation pipes. There it is. Starting from the first floor, we have two different plans, one of which is called 1 Mechanicals, and the other one is called 1 Plumbing. It's almost as if the different floors that I have become two different plans. We have set this up in a way which we can see the canals and the heating and cooling systems in a layer, and we've also set that in another layer we will be able to see the drains, vents, and the irrigation pipes. We will become more familiar with these settings as we go further. So to open each view, we have to double click on it. For example, I just double clicked on plumbing, and a tab has been added here. Tab 1 Mechanics, in which we can see the canal, and the other is 1 Plumbing, which you can't see the canal anymore. In fact, the canal has been drawn, but we've set it in a way which we can't see it in another layer. We did it so we could control the other things better. It is possible that you may see a whole different structure in other projects than the one that you see right here. In the future videos, we will learn all about how we can change the entire structure right here and have a more appropriate structure depending on the project in which we are working. Okay, so if we close these two windows, we have an X mark right here. Let's say I close this by accident. Now what should we do? If that ever happens, we have to go to the View tab and click on User Interface and go right here and check this Project Browser box. And then it will appear right here. So I will reopen that, and when I check the Properties box, I will see the window right here. We also have a bar below the drawing area, which is called View Control Bar. This is a bar for controlling the views. We have some other items like the scale, or the detail level, or the visual style. For example, do we want the style to be shaded or hidden line? And we also have some other items as well. All of them go into this bar, which again we will become familiar with it later. So we call this View Control Bar. We also have another bar at the lowest part of the software, which is called the Status Bar. On the left of it, we always have some explanations. When nothing has been selected, we see some general explanations, which, as you can see, is click to select something, and some other things. So if I select a tool or command, for example in the Systems tab, I will click on the duct command, and then it will give me some explanations about the duct command. So if I select a tool or command and then I don't know what to do with it, or for example if I have forgotten how to work with it, I could just read those explanations about it. In another part of this bar, which is called Work Sharing, or in other words, we can say that our work sets go right here. It includes these settings related to a group work onto a single file. So another section which is called the Options is for all the different styles which we can have for a project. For example, if I want to go from point A to point B, I might have some different ways to go there. So I can choose which one of them I want over here. And also on the right of this bar, we have some tools by which we can control the selection of the different items. For example, I'm going to want the pinned items not to be selected. It really comes in handy in such cases. Or I might want the linked items not to be selected. So I can control and manage the selections by going to this part right here. Up here we have another bar which is called the Quick Access Toolbar. It's the toolbar for the quick access. We can put some of our frequently used tools up in this bar so we can use them faster. And just like all the other softwares, up here we also have the open and save options. Or for example, I might have to put lots of dimensions on the project. Or I might want to see it in 3D or see the section. I can easily and quickly access these options right here. The main location for each of these options exists in each of these tabs and ribbons. For example, these two 3D view and section, we can find them in the View tab. As you can see, there they are. I've also put them up here so that I have quicker and faster access to them. So I can add each item that I want up here to this toolbar. For example, I'm going to go to the Systems tab and then right-click on the Duct command and then click on Add to Quick Access Toolbar. Alright, so now the Duct command has been added to the toolbar, and if I click on these arrows right here, we will see the Duct tool. So depending on the size of my monitor screen, I might see all of the tools right here, including the Duct tool as well. Or we might see a couple of arrows right here which opens into a drawer and we can select the duct. The placement of this toolbar is also changeable. For example, as you can see, it's above the ribbons bar. So I can right-click on it and then click on Show Quick Access Toolbar below the ribbon. As in, this toolbar will be shown below this ribbon. So as we click on that, you will see it down here. Now, because nothing else is blocking the way, we can also see the duct command. So I can right-click, and then I will click on Remove from Quick Access Toolbar so that the duct command would be removed from here. And now it's gone. Another thing we can do is that we can change the order of all these commands. We can just go to Customize Quick Access Toolbar, and when we do that, a window will pop up, and I can select any item that I want and click on these arrows to move them up or down. So let's just cancel this. Now, if I want to move this toolbar back up, I can just right-click and then click here on Show Quick Access Toolbar above the ribbon, meaning that this toolbar will move up. And as you can see, it went back to where it was. You can do this with the option bars as well. As you can see, we have it below the ribbon right now. I can just right-click on it and then click on Duck at bottom. As you can see, it just moved down. So let me select the Duct shortcut, and as you can see, it's down here. So we could just right-click again and click on Duck at top, and then it moves back. So it's possible that you may be working with different systems, and you might see that the location of this options bar differs. So remember, this is how you can change its place to where you want. Up here we have a section called Info Center, which will expand if I click on this drawer. And if I'm looking for something, I can search its name up here. For example, I'm gonna type in pipe and then press enter. And when I do that, my browser will open, and from the Autodesk website, the software's help will open, and then I can see some explanations about the pipe. But remember, depending on my geographical location, this page may not load, and the browser might go back to Autodesk's first page, in which case I can just use a VPN. Okay, so now we've just learned about the different sections and parts of the software, and we also know what their names are. From now on, we can work more easily with the software and give addresses more easily and continue our drawing. Now, another good feature that Revit has is the thing about the tool types. So if I move my cursor onto each tool, a box will show up including some further explanations related to that tool. After a while, this box may expand more and give us some further explanations using images or videos about that tool. Actually, here's an example. I'm going to move the cursor onto pipe, and after about half a second, the box will expand, showing us more information. I can also see the image of the pipe. Now, for example, I'm going to go to the Modify tab and linger a little here on Trim Extend to Corner. And now, as you can see, it shows me a video on how this tool works. It just clicked on two walls and connected them. Also, when I first go on it, it says video is loading. So it is possible that just like this pipe tool that I just lingered on, and after a little bit it would show me a picture or something like a video. So as you can see, in the first line, it's showing me the name of this command or tool, as well as two letters in the parentheses. The initials for pipe is PI. These two letters are actually the shortcut for this command, meaning that if I want to use this pipe command, not only I can click on its option over here, but I can also go to my keyboard and press P and I. And after I did that, I neither pressed on enter nor the space. I did nothing. We only just entered the shortcut PI. Or we can press DT for duct. You can see it just selected the duct command. Let's go to the Systems tab and over to the duct. And in the parentheses, it says DT. Now, some tools have shortcuts, some of them don't. So how can we see all of the shortcuts available? Does it have a chart? Or am I able to add a shortcut of my own? For example, let's say that maybe the T key of my keyboard is broken. And now I want to change the shortcut for the duct from DT to DD, for example. So to do that, we go to the View tab and User Interface, and then click on Keyboard Shortcuts. So can you see right here how this box just expanded? The shortcut for this keyboard shortcuts tool is actually KS, as in I can press on the K and S keys, which are the first letters of keyboard and shortcuts. So a window pops up listing all of the tools I have available. Now I can go here to Filter and choose which tools I want to see. Or we can just move up here and type in and search a command or tool. But first, look right here before we search anything. You can see Properties here. It's that Properties window from earlier. It's so important that it has given it 3 different shortcuts. It's PP, Control 1, and VP. Now let's cancel all of this for a second, and let's close the Properties window. Now I press VP from keyboard, and as you can see, it got back. Pressing VP, it opened again, and Control 1, and here it is. We also have another way to open this Properties window. We can just right-click and click on Properties. Now, if I right-click again, I can see that the Properties option has a check mark, as in it is shown right here. If I remove the check mark, it goes away. So let's check it again. So the properties window is so important that it has 3 different shortcuts, and we can also open it by this right-click way. Alright, now let's go back to that window, View, User Interface, and Keyboard Shortcuts. Now in this search section, I'm going to type in duct, and then all of the commands which include the word duct will be shown right here. Alright, now the duct command itself. It's also showing me the path of it. It is Systems tab, HVAC panel. And down here we also have a box named Press New Keys. So I'm going to enter the letter D from the keyboard twice. And remember, it's not so necessary that I hold the Shift key to make them capital, because then this would happen. It would become Shift and D. So I'm going to press DD, and it would show me the letters in capital by default. Now, if I click on Assign, if the shortcut isn't already chosen for a different command, I would be able to see it right here. So now I'm going to click OK. And from now on, if I press the D key twice, the duct command would open for me. Or I could just press DT, there's no difference. Both of the shortcuts would work. Okay, let's do that again. We go to View, User Interface, and Keyboard Shortcuts. I'm going to search duct, and now I want to delete this shortcut. I'm going to click on it, and then it gets selected, and then I click on Remove. So now what if this shortcut has already been used? For example, I know that this DF is for duct fitting, and I want to assign the same thing for duct as well. And then it shows me a message saying the shortcut DF is currently assigned to the command duct fitting, which means that it's already been assigned for the duct fitting. And below it gives me an explanation saying that I can have a repeated shortcut, and it shows me how I can do that. So if I click OK, this shortcut would be assigned to both of these tools, and if I had clicked on cancel, nothing would have happened. Now let's click OK, and once I press DF, still nothing would happen. So look down here at the status bar saying that the DF shortcut is also for duct fitting. And as you can see, they can change because I am currently pressing on the up and down arrow keys on keyboard. And as I do that, the command would switch from duct and duct fitting. Now it's on duct, so I'm going to press enter. As you can see, it shows me the duct command. So again, let's press DF, and then the duct fitting command would be selected. Okay, so you can have the same shortcut for different things, but it's best that you don't. So I'm going to go to View, User Interface, and Keyboard Shortcuts. I'm going to search duct, and then this DF shortcut, I'm going to remove it. Alright, now that you have become familiar with the software space, we also want to talk about zooming, panning, and rotating. These actually will become so practical for us as we go further in drawing different objects. So as you can see right here, I have drawn a canal, which you will learn how to do that in the future episodes. Because right now, we don't want to talk about how we can do that, we just want to become familiar with zooming, panning, and rotating. Okay, now wherever I place my cursor, and then roll the scroll of the mouse upwards, the page will zoom in for me, revolving that center. Or if I roll the scroll downwards, it would zoom out. For example, if I place my cursor here on this duct fitting, and then roll my scroll upwards, as you can see, it would zoom in with my cursor as the center. Now, if I roll it downwards, it would zoom out again with that same center. Alright, now that I have zoomed in, I want to move the page around so that I can see some other things. So I'm going to click on the scroll pen and then drag it around as soon as I see this cross cursor. The page will move around for me so that I can see the other stuff. We did that by clicking the scroll. Again, we can zoom in and zoom out by rolling the scroll upwards and downwards, and we can pan or change the places of the screen by clicking and holding the scroll. Okay, now if I am in a 3D space, I can also practice rotating over there. So to go into 3D space, I can go to Quick Access Bar and then click on this house icon or default 3D view, which brings us to the 3D space. Now if I hold the Shift key and click the scroll at the same time, it would show me two round arrows as the cursor. And as I'm holding the Shift key and the scroll from the mouse at the same time, I can rotate everything. Now, if I click on an item so it would be selected, and then do that rotating thing by holding the Shift key and clicking the scroll, with this selected item as the center, everything will rotate. As in, the center of my rotation would be this item right here, and all the other items will revolve around it. So I can rotate by the Shift key and the scroll key and see my model from different angles. This cube up here that we see, this one is called the View Cube or the D Cube. Now if I click on this bottom edge right here and drag it around, that rotating thing would also happen for me. And even if I click on the different parts of this cube and drag it around, I can rotate the model to different angles as well. Actually, this item may not be too easy to control, but I can do the rotation using the Shift key and the scroll key more precisely. We're going to start with modeling ducts. Now, if we go to the mechanical group and choose one of the elevations, and by those we mean the east, north, south, and west views. For example, we're selecting the east. So we can see its view. And as you can see, we have two different levels here. Level 1 and level 2. One at the height 0 and the other 4,000 millimeters. So now we want to draw some canals in the level 1, which would be somewhere around here. And for now, we're not going to pay attention with the coordination of our canal with all the other objects. We just want to draw some spontaneous canals so that we become familiar with this command. And then we're going to take the things that we drew to a sample project and check it out over there. So we go to One Mechanic Plan so that we can draw the canal onto the first level. We go to the Systems tab and click on the Duct command, or we could press the D and T keys from the keyboard, which is the shortcut for it. So to draw the duct, we can click on an empty space on our page. We can also zoom in a little bit, and we're going to give it a little bit of angle in the second click, and now the third one, and the fourth click. As you can see, this command is continuous, and after each click that we apply, the necessary fitting duct, or actually the curve, would also be created between two straight ducts. So that's how we draw some ducts. Now let's go check to see what its cross-section looks like, and what are the measurements, and in which level are we drawing, and settings like that. Now to cancel the duct command, we can press the escape key on our keyboard twice. Let me click some ducts again. Click, click, click. You see it's drawing ducts for me continuously. If we press the escape key once, the continuation would stop, but the duct command would still be activated. So we can go to a different place and start drawing ducts again. But if I want to cancel the command completely, I can press the escape key, the one that you see on your keyboard. We can press it twice. You see the command has been canceled. Or we can do something else. We can go to the ribbon and then click on Modify, and then the command would be canceled. Another thing that we can do is that we can right-click and click on Cancel. This cancel option would actually stop the continuation. It does the same thing as pressing the escape key once. But if we right-click and click on cancel again, the entire command would be canceled. So we had three different options: using the escape key, using modify, and right-click and cancel. Now I want to delete all of these ducts that I just drew so that we can talk about some other things. We can select the drawn items by clicking and dragging. If we click on the left side and then drag our mouse, each item that would go completely under that box would be selected. But if only a small part of it is included in that box, all of it wouldn't be selected. We have to hold a complete item. So this was for clicking from the left. But if we drag from the right side, even if just a small part of an item is included, all of it would be selected. You can see it's been highlighted. We're going to go down this fitting, this duct, and this one. So don't forget about these two small points when trying to select your items. If you're clicking from the left side, you have to include the entire item. But if you're clicking from the right, even the small parts would take the whole items. So after we select our items, we can go here and click on delete, or we could use the shortcut DE, or we could just press the delete key from our keyboard. So you have three different ways to delete your drawn items. Alright, so again we go to the Systems tab and click on the Duct command. But before we start drawing our canal, first we have to clarify what we want our cross-section to look like, and how do we want the fitting ducts to look like when they go between two straight ducts. To do that, we go to the Properties window and click on this drawer here so that we would have this list. We have three different parts: oval duct, rectangular duct, and the round duct. Oval is for drawing ducts with oval cross sections, and rectangular is for drawing ducts with the cross section rectangular, and round is for drawing ducts with circular cross sections. Now we have some different subgroups for each of these groups, which are actually called different types. For example, for the rectangular duct, we have 4 different types, which are indicating the elbows or the connections. Now let's go see what they look like. For example, I can go select the radius, elbows, tabs. Let's click on it. So the type of our cross section is rectangular, and its cross section is radius, elbows, tabs. Now the next thing that we should do is that we have to enter the dimensions of our cross sections. We can do that by either going up here to the options bar, or we could go to the properties window and this section right here. And as you can see, this dimensions option is so practical that Revit has separated it and put it here in the options bar so that I would have quicker access. So we're going to click on it and we have width. And for example, we're going to enter number 1000. And remember that our unit is millimeter right here. Later, I'm going to show you where you can check to see what your unit is. Okay, so I'm going to drag the mouse pointer out so that the number would be applied. And now I'm going to put it in height and click so that we can enter a number for the height of our duct. So we're going to type in 800 millimeters and drag the mouse pointer out again. So by now we have selected the type of our connections as well as the dimensions for our cross section. Now we have to decide that this duct that we are drawing, in which level would it be drawn compared to the level that we are already onto. To check which level we are on, we go to the Properties window, and right here, Reference Level. we can see it's level 1. This is actually the level in which the one mechanical view has been drawn on. So we go to the options bar. Here the middle elevation would actually be the height of the center of our cross section compared to the surface of the level, and we have to determine that. In other words, the height of the center of the cross section compared to the reference level. It's 2,750 millimeters. But for example, we're going to enter 3,000 so that it would be drawn 3 meters high. Now we're going to click and zoom in a little and move the mouse and click again. For the continuation of the canal, we can determine the facing of the ducts by moving our pointer, as in we can give it an angle, and this angle could be from 0 to 90 degrees. And as for the height, we can either guess it using our eyes, or we could just enter the number that we want from our keyboard. I'm just going to enter the number without clicking anywhere. 5,000. Now I press enter, and as you can see, it just drew the duct for me. And now from the axis of the cross section up to this point, it's 5 meters long. Now again, to continue our work, we're gonna determine the angle by moving our mouse around. And I'm just gonna use the numbers that I see, 6 meters, and then click. Now we go to the right, and this way we can continue drawing our canal with the height 3 meters. Now let me press the escape key once so that the continuation would stop, but we still need the command to be activated. 1,800. And the duct command is still on. Now we want to add some branches to this piece of duct that we have drawn. We're going to click and click again. Now we press the escape key once. So to draw branches, we can either click on this central line of the duct and then escape, or here on the outer edge of this side, we can click and press the escape key again, or we can go to this side and click again. It really makes no difference. No matter where I click, these branches would be drawn for me. So I'm going to click escape again so that the duct command would be cancelled. And now drag the whole thing so that it would be selected, and then press delete. Remember to learn the duct shortcut right here. It's DT. You go to your keyboard and press the D and T keys. Now we want to know what this radius elbows tabs means. Let's draw a piece of duct. Click, click, and escape. This little connection right here, which is also called an elbow, it has a circular round shape. It's like a curve. We call this in Revit a radius elbow. So now you know why it's called like that. So now you know what this radius elbow is. So we're going to have this radius elbow wherever we need a connection. Now we want to draw a branch. Let's make our dimensions a little smaller. We're going to enter 500 and 500 again. Now we're going to go here, and we said it's no different if we click here or here or here. So I'm going to click and move the mouse around and click again and escape. So now this branch has been drawn. I think we could see it better if we view it in 3D. Let's go to the quick access toolbar and click on default 3D view so that we can view our drawing in 3D. Now we can hold the shift key and then click the scroller, and at the same time move this around so that I can rotate the drawing. Now I'm gonna roll the scroller upwards so that it would zoom in for me with the pointer as my center. Downwards is zoom out and upwards is zoom in. So we can see the type of our branch. you can see that its form is kind of like it's been stuffed into the duct. Or we could say that the branch looks direct, as in from this height of the duct, a small part has been cut and this has gotten out from that part. We go to the View tab, and if we click on Tile Views, then these two tabs that you can see are open right next to each other, we would then be able to see them both in a single view. You know what tile means, right? So we click the Tile Views, and now my drawing area has been split into two, and in one part of it I can see the 3D view, and in the other I can see my plan. It's the floor plan that we drew. So for the connection type, as we said, we have this stuffed-like shape, or what we call a direct branch. In Revit, we call that a tap. What was the type of our duct when we click on it so that it would be selected? In the Properties window, it also tells me its type. It's radius, elbows, taps, meaning that if an elbow should be added for me, it would look like this. And if I am going to add a branch, it would be in tap. Again, I can go to the View tab and click on Tab View so that each window would occupy an entire page for it. And then I can see each view by going into its tab. In the Systems tab and the Duct command, we are going to open this drawer and select Radius, Elbows, Tees. We just want to see what other types of connections do we have. And now for the dimensions, like the one before, we put 1000 and 800. And can you see how it's showing me the direction by dash lines? It would be helpful if I need them while drawing. So I'm going to click and move the mouse horizontally and click again. And now drag it vertically. And as you can see, it's also showing me the direction by dash lines again. I'm going to click again and escape once. So this is that radius elbow. Now we want to add a branch. We're going to click and click again. And now escape. As you can see, it just created a triode. You can see that it has split my duct into two parts with a fitting right here. Now if I view this in 3D, it would look like this. The triode, which here we call a T, we can see that in this branch. So if we use the radius, elbows, taps, the branch would look like a tap. And if I use radius, elbows, tees, the branch would get a triode shape. Let's go to the other type. We have mitered, elbows, taps. We can guess what the taps part is. It's this direct branch that we just saw. But what's a mitered elbow? Let's go draw that so we can see. I'm going to click and select it. And we go to the area and the first click and the second click vertical. And then click again and press escape. So as you can see, this elbow that we just got, it has a corner. It has a 90-degree angle. We call this one a mitered elbow. So now we got radius elbow and mitered elbow. And now for our branches, we're going to enter 500 for the width. And with the height 500, click and click. And our branches are taps. Now the last connection type for the rectangular ducts is mitered elbows, tees. Now let me enter the previous dimensions, 1000 and 800, and click and click. Now click again and press escape once, and now the branch, click, click, and escape. So now we have radius elbows and mitered elbows. The branch type is tabs, and on here we have tees. These are the 4 different types which we had under the rectangular duct group. We also have very similar types for both round and oval ducts as well, which we will practice some different types as well later on, and we will model them and see how we can draw them. You can see the radius and mitered elbows in this picture, and we can analyze them based on the airflow that goes through them. The air is coming in. In the radius elbow, it goes very well to this direction. And in the mitered elbow, because of the sharp angles that we have, the flow would slow down at these corners, which lowers the pressure of the air. So this is one of the cons of the mitered elbows. But what pros does it have that make it worth using? Let's go back to our Revit. And here in the area, first I'm going to go to the wall command from the architecture tab and draw a piece of wall right here. Now let's say that we have a canal, which actually let me go draw this canal by radius elbows. Okay, now we go here. Actually, let me go a bit further, and here we go. Okay, so here's our canal. If we use the radius elbow, we can see that this corner of the wall is interfering with our elbow. Okay, now let's say that I don't have the permission, or I don't even have the enough space to move this canal around upwards or to the right so that I can fix this interference. So to solve this, what I can do is I go and use a mitered elbow. So I'm going to select that elbow from the Properties window and select the rectangular mitered elbow and replace that. So you can see that the problem's solved. So in case I have limited space, I can use the mitered elbow, but as we've also said before, this elbow lowers the pressure a little bit. And to solve that issue, some vanes can be included into the elbow. They are called turning vane, which helps the air flow a little easier. Now, before we discuss the other points about drawing ducts, first let's talk about how we can adjust the units. Now, to adjust those units in the project, we can go to the Manage tab and then click on Project Units, or we could just use its shortcut, which is UN. Now, in the window that pops up, here in the Discipline section, the items have been grouped. We have a common option, which includes some general parameters, things like the length unit. If I click on the box in front of it, another window would pop up for me where I can adjust those units over there. We're going to go to Units, which is on millimeter right now, and in rounding the number of decimals, and in the unit symbol, I can choose a symbol so that it would be shown as the unit. Okay, now we go here to the HVAC part, and then we find the duct size. Now, if I click right here, it tells me that my canals are being drawn with the unit millimeter, and they have no decimal places, and I also have no symbols. Now I'm going to change this to inches. It's possible that in some projects your units would need to be inch. And I'm going to have 2 decimal places, and for the unit symbol, I'm going to select in, which is short for inch. Now we're clicking OK. Now if I go to the Systems tab and click on the duct command, in the options bar I can see that both the width and the heights are shown in inch. I can also see this IN, short for inch. Now I'm going to press the escape key to cancel the duct command. And now if I click on any of the ducts, I can see that their units have been converted to inch. The duct's dimensions were 1,800, and they've been multiplied by 25.4 and converted to inch. What I mean is that if I go here and divide 1,000 by 25.4, I will get the number 39.37. And the same thing for height as well. So now I know that the unit of the canals I drew was millimeter. If I press the UN shortcut again, And then go to HVAC and find the duct size and open it and change the unit back to millimeter. And I don't want no decimals, but I still want the millimeter symbol. And clicking OK and OK. We're gonna start modeling the electrical items. Over here under Project Browser, we've got this important discipline called Views, as well as some other disciplines which are not as important right now. This Views discipline tells us which level we are in, which plan for which level, like if we are in the floor plan or the ceiling plan, or section 3D. And now we have this electrical discipline, which has two subdisciplines of lighting and power. Now if I expand each of them, I can see floor plans and ceiling plans. And under subdiscipline power, I have floor plans, 3D, and elevations. So it seems like our first level or floor has two floor plans, one of which called one lighting and the other is called one power. So we realize that they are both related to the first floor, but in each one of these floor plans, something has been made invisible and instead something else is visible. Let me rephrase that by an example. For instance, in this one lighting floor plan, the cable trays and conduits have been made invisible. But instead, some other things like switches, outlets, or protectors are visible so that they are easier to see and select and assess. On the other hand, in floor plan 1 power, all of the items are visible. We could also see cable trays and conduits there. So, this is the difference between these two floor plans. Now, about how come we can't see the cable trays and conduits in this floor plan, or how they've even been turned off, we're going to find that out later. But for now, we just want to begin drawing the cable trays in this template we have opened. So let's go see what a cable tray even is. If you pay attention to this image right here, you'll notice that the cable tray is this U-shaped item, which makes a way for the cables to go through easily. This cable tray actually creates a space through which the cables can go straight ahead and safely, and it also keeps them from getting harmed. For example, it keeps this cover on them safe from being cut or bruised. So this cable tray creates a safe path for these cables to go through. What we are about to do now is we are going to draw this U-shaped cable tray. But before we do that, let me show you another picture right here. Here are a few actual cable trays stored next to each other, and this is one of them. I'm going to zoom in so you can see it better. You can see that its end is U-shaped, which would be installed in a way where it can cover a few cables under it. There are actually some different types of cable trays. Let's take a look at this image right here. There are generally 5 different types to cable trays. One of those types is, as you can see here, is called trough. And let's go see an actual picture of it so you can see what it looks like, and then we'll go back. This is a trough cable tray. As you can see, it consists of this bed at the bottom and 2 walls on either side, which in fact they are unattached in the first place, but then they become attached to the bed to create this U shape. We call this a trough. Now, this type of cable tray could either have a perforated bottom, or it could just be solid and without any holes. We call the one that has a bottom with holes in it ventilated, because those holes would be ventilating the cable tray. So since it has so many holes, the air could flow in and ventilate the tray. In case, let's say that some heat is accumulated over there, those holes could help ventilate the tray and keep the cables from overheating. It is also called perforated. You might have noticed these single-use only plastic tablecloths which have these perforates in them by which you can cut the tablecloth. Those are also called perforated, so this perforated means that there are some holes by which the air could come in and go. So there's either ventilated or perforated, or the cable tray could be solid bottom. This means that its bed or bottom is solid and has no ventilation holes. So there goes one type of the cable tray. There's another type which is called channel, and this channel cable tray in the first place was just a foil, and then its sides have been bent to create this U shape. It looks something like this picture we saw earlier. This is actually a single piece. Its sides aren't attached, but the foil sides have been bent to create this U shape. Now, this channel cable tray could also have a perforated bottom. It could have a few punches, and those punches could be in different shapes. Or it could just be simply solid bottom, which is something like what we see next to that. Now, about the difference between trough and channel cable trays, we could say that trough is used for when we have so many cables and the weight is too much for the cable to handle, so it needs more resistance. But on the other hand, channel is thinner, as you can see. Now, the next type of cable tray is called ladder, which, as you can tell by its name, is going to be a ladder for the cables. It also looks exactly like a ladder, and it has some pieces as the steps and the two sides holding the steps together. In cases where we would be needing access to cables from both sides, we could use this ladder cable tray. Or for example, when it comes to the risers and we need to maintain a vertical direction, or if we want to install the cables on the wall. These are actually some of the cases where this one would be most useful. There's another type to the cable trays called wire mesh, where so many wires have been welded together to create this mesh shape. Then the cables would be covered by this. As for the last type of cable tray, it is called single rail, where there's a rail in the middle and some hooks are attached to its sides, on which the cables would go. Let's see a picture of that. You see, this is what it looks like. There's a rail in the middle, and then there are these hooks on the sides on which the cables are placed. As you can see here in this image, these cables which are going through, there are some distance between each hook, and it seems like the cables are weighing down between them. So they are going forward kind of wavy, but there are actually some cables which are not supposed to be going that way or be weighing down. For example, the optical fiber cables. They're not supposed to be having so many curves. So for those cables, the last three types are not suitable, and it is best if we use channel or trough cable trays instead. And even if we use trough or channel, it is best if we use solid bottoms. That's because since there are perforations on the ventilated ones, the cables might bend into them. So each type of these cable trays, trough, channel, ladder, wire mesh, and single rail, are suitable for certain cases. I'm about to start drawing cable trays in Revit. But before that, first and foremost, I'm gonna have to go over to the project browser window and into the plan which shows my cable trays. That plan would be the one that's called Power. But before we open this plan, first let's go take a look at one of the elevations. For example, I'm gonna take a look at the east elevation. Now here in this template, we have a level 1 which is at elevation 0, and then we have another level which is at elevation 4,000 millimeters or 4 meters. For now, here in this video, we're just going to try to draw some cable trays for practice, and just generally we would become familiar with how we can do it. After we learn how we can draw them, the whole process is going to become completely project-oriented, and then we're going to work on a project for which we have the architectural and structural plans, and then we're going to draw the actual cable trays for that project. So remember, when I open one Power floor plan, I'm going to be drawing the cable trays for level 1, considering that this would be the ceiling for this level 1 or the floor of level 2. So we're going to be drawing the cable trays around here near the ceiling. The view in which we could see the cable trays was one Power. So I'm going to go over to one Power floor plan, then double click on it to open it. When we go further, you will learn how you can reorganize and customize this entire Views Discipline settings in this project browser window. as well as how you can make some items visible in a view or invisible, or how you can turn them off. But anyway, we're gonna go over to this one power floor plan and we're gonna start drawing the cable tray. We could also close these extra views we don't need for now. To start drawing the cable trays, first we're gonna open the right view. We're gonna go over to the Systems tab, and then we're gonna click on Electrical to open its drawer, and then we're gonna click on the Cable Tray command. Because of the size of my screen, the electrical commands have been collapsed together, and therefore I can only see the name of this electrical panel. But if I just move my cursor onto it, without clicking, this drawer will open, which contains all of the electrical tools and items which we need for drawing. Now, to make the whole thing a little easier, I'm gonna go onto this electrical panel, then I'm gonna click and hold it, and then drag it all the way to here. Do you see the white space which appears? This is gonna be the point where we let go of the panel. The thing that just happened is that the panel just expanded here, and the other panels have scooched over, and another panel, for example, this plumbing, has collapsed instead of electrical. But in case your screen is wide enough to show all of them, then all of these panels would be expanded in the first place and you wouldn't have to move anything. So now back to what we were doing. We went to the Systems tab, then the electrical panel and the cable tray command. Here in Revit, whenever we activate any command, we're gonna have to go over to the Properties window and check to see what types and fittings that selected command has. So I'm gonna click to open this drawer, and as you can see, we have a sector here which reads Cable Tray with Fittings, and another which reads Cable Tray without Fittings. I'll tell you the differences between these two later on, just ignore it for now, and instead let's see what we have under with fittings. There are 5 types listed here. We discussed and learned about them in the previous video, and we know what channel and trough look like. Channel was the one which had bent sides, creating a U shape, and the trough type was the one where the bottom and the sides were separated from one another, but they've been connected and attached to each other to create the cable tray. Now for channel and trough, we said that they could have holes, they could be called perforated or ventilated, or they could just simply have a solid bottom. But here in Revit, they have not been divided like we discussed, but instead their names are simply channel, trough, and solid bottom. For example, we could say that this channel and trough are ones which are ventilated, and the solid bottom might apply to both of them having a single solid bottom. But despite all of this, we can create and add more types as we learned them. But for now, let's just see what these are. Wire mesh was the one which had many wires welded to each other and creating a basket shape. And as for the next type, which was ladder cable tray, this was actually the one which looked exactly like a ladder. Now, under the sector cable tray without fittings, we also have wire mesh cable tray like we had before, as well as single rail cable tray. For the single rail, we said that there was a rail in the middle and some hooks are attached to it from its sides, and the cables sit on those hooks. So those types we've talked about, we have them here. Before we start drawing, we're going to have to check our plan to see the cable tray type it requires, and then we would select one of these cable tray types and draw it. As an example here, I'm going to select channel. So the first step of drawing a cable tray is selecting the right cable tray type. After that, we're going to go over to the options bar to specify what the width of the cable tray should be as well as its height. For example, let's say I want the width of the cable tray to be 60 centimeters. So I'm just going to click over here. And since my measure unit is millimeter, I'm going to put in 600 millimeters. Now I'm going to want the height of the sides to be 5 centimeters. So I'm going to click and put in the number 50 because my unit is in millimeters. Now before we continue, let's go see how we can specify the measure unit of the project. If we go up to the Manage tab, we can find an item which is called project units. Also, do you see the UN in parentheses? That's its shortcut. So if we want to use that, we could just go over to our keyboard and press the U and N keys. After the shortcut, we don't need to press anything else like the Enter or the spacebar. We just enter the shortcut U and N. In this drawer up here, the parameters in Revit have been divided into groups so that they are easier to find. This drawer is called Discipline, so we're going to open the drawer and select the discipline Electrical. After that, we can go over here in the list and find cable tray size. If we click on this button in front of it, then another window will appear. Let me put it over here. And you see it says the units are in millimeters. If we open this drawer, we could change the units to centimeters, inches, and whatever else. Besides that, we can also specify how many decimal places we want to see in the roundings. For example, we might want to see 2 decimal places. We can also decide whether to see the unit symbol or not. If you recall, up here in the options bar, we had 300 millimeters, 100 millimeters. You saw the unit symbol earlier. So again, for the units, we can go over to the Manage tab and then click on Project Units, then go to Discipline Electrical and adjust the cable tray size. Now that we know, we're just going to close all these windows. So it was Systems tab, Cable Tray, and then the cable tray type, and then we put numbers for the width and height. Now this cable tray which we are about to draw is going to be at which middle elevation from the level in which we are, which is 1 power or the first level. 1 power is level 1. Also, if we take a look in the Properties window, we will see that the reference level is level 1. So from this level 1, at which elevation is this cable tray going to be? To specify the number for that, we have the parameter middle elevation up here in the options bar. But what does this middle mean in middle elevation? It means that since the height is 5 centimeters here, the middle of it is 2.5 centimeters. So what do we want the elevation of the middle of the height to be from the reference level? We're going to click here. And let's say we want this to be 3 meters high, which makes it 3,000 millimeters. After adjusting those numbers, we're going to make a click. And also I'm going to zoom in a little. And then I'm going to move to the right and make another click. And let's say we would have a change of angle, so we're going to move down and click. And then move to the right and make the next click. And we could also draw this at a more different angle. We're going to click. Then go over here and click again. Actually, let me remind you that your angles can only be 90 degrees minimum. Like if you try to make it less than 90, do you see this X mark that appears? You can't draw that, only 90 or greater than that. Now click and press Escape. And to see the cable trays better, we're going to take a look in the 3D view. We're going to go up here to the Quick Access toolbar, then click on Default 3D View. Now let's zoom in. Also, I'm going to hold the Shift key and roll the scroller wheel to rotate the view. Now, down here in the View control bar, there's a button called Detail Level. I'm going to click on it, and if I put it on Coarse, I will only see a line for the item. The Detail Level Coarse actually means the least amount of details, and which is this line. If you want to see the least amount of details of a cable tray, it would be a line. Now let's set it on medium, and to have an even better view, I'm going to change the visual style to shaded, so it looks like this. When it's on medium, it'll look like a rectangle which is moving in a direction, so it has more details than just a line. Now if I set the detail level on fine, as you can see, we will have this shape which looks exactly like a cable tray with 2 sides. So you can decide how much detail you want to see of an item by changing the detail level. Now if we look here, we can see the cable tray turns, and then further it turns again, then another turn, and basically we have all of the turns we have created when we were drawing. Now this whole cable tray is positioned at the elevation which I put in before drawing. Let's go to one of the elevations, east, and we could even measure the elevation to make sure. I'm going to go over to the Quick Access toolbar, Then click on the Align Dimension command. Then I'm going to go over here, but it only allows me to select the top or the bottom. But if I go on one of these lines and hit the Tab key, then the middle of the cable tray or its middle elevation will be highlighted. After the middle elevation's been highlighted, we're going to click on it to select it. And then we're going to move all the way down to the level 1, make a click, and then we're going to click somewhere blank for the third time to confirm that line. As you can see, it's at 3000. The entire cable tray line has been drawn at this elevation. Actually, we are also allowed to change the primer elevation which we give to the cable tray, which is something that we're going to learn in the future videos. Actually, here's another thing. If you recall, I told you that in floor plan 1 lighting, we couldn't see the cable trays. But I'm very sure that I did draw them in the first level. I see them in 1 power, in 3D, as well as in the elevation. But in 1 lighting, I can't see them. I'm going to go over to the Systems tab, select cable tray and try to draw one, click. But as you can see, it's not showing us anything but dashed lines. But if I go over to 1 power and click, we can see a preview of what we are drawing. So now let's go see what happens if we try to draw them in lighting. Click, go further and click again. As you can see, if we do that, we get a warning. First, let me press escape to cancel the command. And let's read the warning. It says, none of the created elements are visible in this floor plan we have opened, which is floor plan 1 lighting. So it's telling us that the thing that we just drew is invisible in this floor plan. It's not saying that it hasn't been drawn at all. It says that it has been created, only it's not visible here. It also says how we can check why that is. I'm going to tell you why later, but for now let's just go over to 1 power. We can see it here, but not in 1 lighting. So make sure you don't mistakenly draw your cable trays in 1 lighting and then wonder why you can't see them. You would have to draw your cable trays in 1 power where they are visible. So now we're going to start modeling the conduits or the electrical tubes. When you work with electrical templates, you can see the conduits or the cable trays that you draw over here in the power floor plan. So now I'm going to double click on 1 power to open it. We don't need the lighting plan, so we're going to close it. And now we're going to go over to the Systems tab. Then we select the electrical panel. And in order to be able to select its tools even better, I'm going to grab it and drag it to the beginning of the ribbon, which will expand the panel and we could see all of its tools at once. Now I'm going to click on the conduit command. Try to learn and memorize the conduit shortcut, which is CN. So to have a review, the 4 main MEP commands which we've learned and will be using frequently are first, duct with shortcut DT, then we have pipe with shortcut PI, then we learned cable tray shortcut CT, and now conduit with shortcut CN. So try to memorize these 4 shortcuts because you're going to be using them a lot. So I'm going to click on conduit, and now I need to go to the properties palette to select the fitting type with which I'm going to be drawing. You see here we have 2 groups. One is conduit with fittings, and the other is conduit without fittings. I'm going to tell you about the difference between these 2 groups. It's actually pretty similar to what we had with the cable trays, but this one has a little more to it. We have some types under these 2 groups. For example, this first one is electrical metallic tubing with abbreviation EMT. There's also this rigid metal conduit or RMC. The next one is rigid non-metallic conduit or the PVC tube. These last 2 types are non-metallic, or in other words PVC, and the first 2 are metal conduits. Now let's try to open the electrical settings window. There are 3 ways of opening the electrical settings, the main of which is by going over to the Manage tab, then opening this MEP settings drawer, and clicking on electrical settings here. This is the window. Let me close it. And now for the second way. We could go over to the Systems tab, and right next to this electrical panel, we can find this little arrow right here, which if we click on, once again, the electrical settings window opens. As for the third way of opening this window, we could just use this shortcut, which is ES. So those were the three ways of opening this window. Over here in the conduit settings section, we have a branch with the name size. If I click on size here, then in the right field in the window, we can see the standard which we can set and the different sizes in a list. Let's go check out the standards real quick. First, we have EMT, just like what you saw in the properties palette, that this EMT stands for electrical metallic tubing. Next, we have IMC, which stands for intermediate metallic conduit, and this RMC stands for rigid metallic conduit. So it seems like the rigidity of the conduits is increasing gradually. For example, this electrical metallic tubing has the ability to be bent. As in, when you install this type of conduit, you could use a conduit bender tool to bend it. But on the other hand, the RMC conduit is more rigid and it cannot be bent. So instead, we could just use some extra fittings in order to change its direction. As for the IMC type, this one's actually something between these two. So these are the three standards we have for the metallic conduits. Now if I select any of them, any of these standards, for example this EMT, then below we can see this column called trade size, which is something like the nominal size which we had for the pipes. Then we have ID, which is the inner diameter of the tube, and OD, which is the outer diameter. So when you want to order your conduits, you won't say that you're looking for a tube with ID 15.80 centimeters and OD 17.93. That would actually be too hard to do. So instead, there's been an agreement that for tubes with this ID and OD, we would refer to it with this name right here. For example, we would say conduit 16 or conduit 21. This means that this is a tube with this internal diameter and this outer diameter. So these sizes aren't named consecutively. We don't have conduit 18 or conduit 40. Instead, we have the sizes that are defined here, which are based on the standard. After those three, we have another column which is named minimum bend radius, which is for bending the conduits. No matter whether we are bending the tube itself or we are using a fitting. Either way, the minimum bend radius that each one of these sizes are allowed to have are as followed, and they are not allowed to be less than these. But they could be greater. You see, some of the cables which are going to be going through these conduits have certain bend radiuses, and they shouldn't be bent over their limits. Therefore, the minimum bend radius allowed is defined here, and if you try to bend your conduits to a smaller radius, you'll get a warning saying that you're not allowed to do so. But you'll have no problem trying to bend it with a greater radius. We will see and understand that better when we are drawing, but I just wanted to give you a heads up here. So keep this first one in mind, 15.8 and 17.93, and now IMC. Do you see how this one has different values? 16.67 and 20.7. Now for RMC, you see all our trade sizes are the same, but the IDs and ODs are different. What I'm trying to say is that each one of these standards have different sizes, and again, so is the rigidity in each one of these standards. As for the last two RNC standards, they are the rigid non-metallic conduits, which are also known as PVC. I'm going to select this RNC Schedule 40, which has these sizes, and then Schedule 80 has the same outer diameter as Schedule 40's, but its inner diameter has decreased. It has changed from 15 to 13. So that means that this one is thicker, and so the tube is also more rigid and more resistant. Usually for conduits which are meant to be installed internally, we use the non-metallic conduits, and for the conduits which are meant to be installed externally, we use the metallic types. So based on these standards we have here, we could define and select different types of conduits as well. If you recall, we also had the same thing with the pipes. I'm going to open the mechanical settings window. Do you remember what its shortcut was? There you go, MS. We said that we could go to the pipe settings section, then open segments and sizes, where we could select the segment we needed, and then we had nominal ID and OD. So the same thing also goes for the conduits. We could open the electrical settings, ES, then go to conduit size, and here instead of segment we have standard. It's standard because we have the same sizes for the same material, and the only difference in these standards is in their rigidity and thickness, based on which we could select any of these standards we need. So we said that we needed to go to the Systems tab, then click on the Conduit command, and in the Properties palette we can see the different conduit fitting types. We've also talked about EMT, RMC, and RNC and their differences, and now I'm going to select one of them, for example, EMT. I'm going to click on it to select it, then click Edit Type to open the Type Properties window. I'm going to also expand it from the side, then I'm going to also expand the column. Now for this type, with this name, the standard and the sizes which are going to be applied to the tube, the standard which has been defined over in the electrical settings window is here. Now what about the fittings? These are the fittings we have for this type: bend, T, cross, transition, and union. For each of these parameters, these families will be used, and if you take a look at their names, you can see that their materials are aluminum and steel. Let's check another type standard, RMC. You can see that here we have bend, T, cross, transition, and union. So the fittings are all the same, but the materials are all aluminum. And also if we take a look at the RNC, you will see that the material that's been defined for each one of these parameters is PVC. The exact same thing goes for the without fitting types as well, as in we have EMT with these fittings, and also the same thing for RNC and RMC. All of the fittings are the same. Alright, now let's start drawing to see what they actually look like. I'm going to be using this electrical metallic tubing from the group Conduit with Fittings. Click to select it. Next, here in this Properties palette, we can find the service type and click on the field in front of it, and enter the service to which this type of conduit is going to be related. For example, this conduit is related to the lighting, so I'm going to type that in here. Then I'm going to press enter, then move the mouse out of the palette. So the service type is in the form of text, which you need to enter yourself. As for the pipes, when we were talking about the mechanical items, we had a system type instead of this, which had a drawer which you could open and select. But as for the electricals, there's a service type which you need to enter manually. Now the third thing we should do is to select the diameter of the conduit we are about to draw. You should find the value of the diameter of the conduit that you draw in your plan. This diameter is pretty much related to the kinds of wires and cables that are meant to be going through this conduit. For example, now I'm going to select the size 16. Next, we have the elevation of the conduit, which here is referred to as the middle elevation. But if you also want to specify your top elevation and bottom elevation, you could do that by going to the Properties palette. Now I'm going to go to the drawing area and make a click. And let's zoom in a little bit. Then make the second click. Then move down and click again. And then press Escape. Now why does this conduit appears in a line? This is actually a tube, so why are we seeing it like this? Do you remember why? That's because the detail level is set on medium. But if I change it to fine, then the conduit will appear in double lines, or just like a tube. Also, if I set the visual style on shaded, there will also appear a shade onto this tube. Okay, so this is the fitting that is put for us, which is conduit elbow. You see, for this type of conduit in Edit Type, we had to find that for the bent fitting, what family should be used. This was the family we've put, which has also been added in the drawing. Now let's say we want to add a branch. Do you remember the shortcut for the conduit command? CN. We're going to continue drawing with the same service type, and the same middle elevation. And now we're going to go click on the conduit. It doesn't matter if we click on this edge, on the axis, or on this edge. Either way, it's going to work, so we're going to click, then move upwards and click again, and then press escape. We refer to the T-fittings for the conduits as the junction boxes. As you can also tell by its shape, it looks nothing like the T-fittings we had for the mechanicals, but instead it has this box shape. It also has a lid, and the conduits reach its sides, and then the cables and wires which come in will be spliced together, and they will change directions to go into the branch. Now let's go take a look at this in 3D. I'm going to go over here and click on Default 3D View, and I'm going to set the detail level on Fine, and the style on Shaded. Now we're going to zoom in. And as you can see, the T looks like this box, but the difference between this junction box and a normal T-fitting is that this one obviously has more details, whereas we know that when it comes to the electrical items, not a huge amount of LOD is considered, and usually we don't have a lot of details. Also, we may have a junction box like this one, where 2 or 3 conduit connectors are involved. So considering the junction box you have, and the size of the conduits that are going to be connected to it, you could be using an item like this one. So remember, when you add junctions to your conduit, you will have this item, which is called a junction box. Once again, I'm going to get the conduit command by its shortcut, CN, then add another branch here, click, and click. Now this junction box right here functions as a T-fitting. Now if we click on it to select it, we will notice a plus sign, which is located over here on this side. And if we click on this plus sign, that'll convert this T junction box to a cross. Appearance-wise, it's not going to change, and the only thing that happens is that another clip will be added here, through which we could connect the conduit. As you can see here, we have 1, 2, 3 clips, and now if I click on this plus sign, you might think that nothing just happened. But if I click on the junction box, I can see that this new clip has been added as well. The previous one didn't have this clip, but now that we've clicked on the plus sign, it's been added to this one. Now if I right click on it, then draw conduit, then I can add another conduit which completes the cross. In case the size of your conduit changes, for example, I'm going to continue this one, right click, draw conduit, and we're going to draw with a different size so we can see how it looks. So for example, I'm going to select the diameter 53, draw to the left and click, and then press escape. As you can see, the transition also looks like a box, so this one's also considered a junction box. The diameter of the conduit on one end is 53, and on the other end it's 16. Also, relative to the amount of diameter we have for the new conduit, the dimensions of the junction box may also vary. Also, notice how we don't have those 2 extra clips in this one, so it's not like we could click on a plus sign to convert it to a T or a cross. This one in itself is a transition. Just like how in the mechanicals we couldn't convert a pipe's transition to a T or a cross, we can't do that to the transition junction boxes for the electricals either. So there goes another fitting. We already know how the lengths of the conduits are limited. For example, let's say we have 3 meters. Now, if it were necessary to connect 2 conduits together, in order to do that we would need to put an extra fitting between them, which connects 2 straight lines of conduits together, and is called a union. Over here in Revit, we could draw our conduits with whatever length we want. For example, this one right here is 1,538 millimeters long. Now if I try to drag to extend it, it has become 6438 or 6 meters long. There was also no problem, so we could draw our conduits however long we want. But when it comes to installation, the lengths of the conduits are limited. So then in order to place that union between 2 conduits, we would need to go to the Modify tab, then click on the Split Element command. Now I'm going to go over here and hover on the conduit and stop at 3 meters because that's the length we want. Click. And now we have this 3-meter conduit, and over on this end of it we have this fitting right here, which is called a union. So a union fitting actually unites 2 straight lines together. So let's review. I'm going to click on this conduit, then click on Edit Type. The bend fitting was this bend right here. Then there was the T-fitting, which, like I said, for conduits, it comes in junction boxes. Then for the cross-fitting, once again, we have a junction box. And the transition fitting also has this junction box family. And lastly, we had the union, which united two straight conduits together. So if you use the split element command to split your conduit at some point, then this union fitting or this family conduit coupling will appear onto the split point. Now, once again, I'm going to go over to the Systems tab, then select the Conduit command, and this time I'm going to draw a conduit without fittings. So let's go see how we can draw them. Make a click here, and another one here, move down and click, then I'll press the Escape key, and now here we have a fitting called Conduit Elbow with two straight conduits. Now the difference between this one and the with fitting type is that in with fitting types, we have a line between the elbow and the straight line, which serves as a border and an indicator of the connection point between these two items. But we don't have that line in without fittings. Now if I also try to add a branch by using the shortcut CN, then click and click, then we will have a junction box for the branch to be created. Also, if the diameter changes, for example, I'm going to change this 53 to 16, once again, another junction box will be placed in between. Also, as for this junction box, which functioned as a T, if we click on its plus sign, it will convert to a cross, and this clip will be added to it, which we can right-click, then click Draw Conduit, and draw one on this side of it. Also, if we go to the Modify tab, then select the Split Element command and try to split the conduit, then once again, we will have this union or the coupling family over the splitting point. So drawing-wise, we can draw the conduits with fittings and without fittings the same way. But a main difference between these two types is actually in their quantity surveying. You see, when it comes to surveying the quantity of the types without fittings, we would get the overall length of the conduit, including its elbow. That means that the length of the elbow itself is also in there. This is as if this entire conduit is a single piece which is bending, and that there are no actual fittings in there. But as for the conduit types with fittings, when we survey their quantity, we would get the overall length of all of these straight conduits. We'll talk more about this later. Now I'm just going to delete all of these, and I'm going to tell you about another difference between these two types. I'm going to hit CN to get the conduit command, and currently we're drawing without fittings. Take a look at the options bar, where alongside of diameter and the middle elevation, there's also the bend radius at the end of the bar, where we can also specify the radius of the bend. We could also put in numbers greater than what we already have in this field, because the number that's here by default is actually the minimum bend radius value, which we've determined over in the electrical settings window. So let's see what that looks like for EMT with diameter 53. I'm going to hit ES, then go over here, check EMT, size 53, it's 269.2. Now in this field we see 269, which is rounded, so we can't see the 0.2. So remember, this is the minimum value, but you can add even greater numbers. Now I'm going to click, move to the right and click again, move down and click again, then press escape. Now after we've drawn our conduit, we could click on this elbow right here. Then we will be able to see its bend radius. I'm going to click on it, and we could change the bend radius to what we want. I'm just going to change this 269 to a higher number, for example 500. Press enter, and now you see how the radius of the bend has become wider. Now if we try to put in a smaller number than 269, for example 200, press enter, then we will get this message which says that this value you've entered is too small. By this too small, it actually means that this value is smaller than the minimum bend radius allowed. So now what are you going to do about it? Do you want to use the minimum bend radius? If we click on this option, it'll change to 269. Let's check the other option, enter 200 again. And if we select enter a larger value, then it'll allow us to edit the value and put in a larger number. For example, we could say that the minimum bend radius was 269, so that'll be the least value we're allowed to put in. So we could use 270, then press enter. So if you specify a value less than your minimum bend radius, then you'll have two options: either replace it with the minimum value or to just choose a greater value yourself. Also, if we know that the wires and cables that are going to be going through this conduit could be bent with a smaller bend radius, then we would have to go to ES to readjust. Size standard EMT, size 53. We're going to select the minimum and then click on the modify size button right here. We're going to replace the 269 to, for example, 150, then click OK and OK. Now if we select this elbow and put in 150 as the bend radius, it'll remain at 150. But if we put a smaller value like 140, it won't be applied and will let us use the minimum bend radius. Now I'm going to change this back to 269, and then I'm going to get the conduit command again, and this time we're going to draw our conduits with the width fittings type. Now if you take a look at the options bar, you'll notice that we no longer have that bend radius parameter at the end. So that means that with the width fittings types, we are not allowed to change our bend radiuses. I'm going to start drawing, click here, click again here, move down and click, then press escape. Now if I click on this elbow, you'll see that even here we don't have the bend radius field. But if we want to find out what its bend radius value is, we could go over to the properties palette and find bend radius here. Notice how it's not even changeable, because this parameter was defined in the family itself. So you can change the bend radius for with fittings, but as for the without fittings types, we could change its value not only here, but also in the options bar and over here in the drawing area. So the main difference between the with fittings and without fittings types is in their bend radius. So here's another thing. If I click on the bend of this with fittings, then I could convert this elbow by clicking on this plus sign to a junction box. But as for the without fittings types, that's not something we can do. We don't even have the plus sign over here to be able to convert this elbow to a junction box. So what if we want to continue in the opposite direction? Then we will have to delete this, then drag to extend this one, then drag to extend the next conduit to connect it to the first one. This is how we will have a junction box. But if we try to convert the elbow to have a junction box, that's not going to happen without fittings. While we're at it, let's have a review on the cable trays. So I'll go to the Systems tab and click on Cable Tray. If I draw a cable tray with fittings, then we will have the bend radius in the options bar. And now I'm going to click, click, move down and click. And then if I try to draw a cable tray without fittings, we would still have the bend radius here. So when it comes to the cable trays, we are allowed to change the bend radius on both types. In cable trays with fittings, just like what we have with the conduits, we could select the bend and click on the plus sign to convert it to a T. But as for the without fittings, we are not allowed to do so. Instead, we will just have to delete the bend, then drag to extend one of the cable trays, and after extending the second one and connecting them together, then there won't be a T. Instead, it's going to be like the side of one of the cable trays is removed to make way for the second one. But on the other hand, for conduits without fittings, the connection will be just like the with fittings and we will have a junction box. Let's check them out in 3D. As you can see, the cable trays without fittings will turn out like this, and it's actually without fittings. But in the cable tray with fittings, we have a T. As for the conduits, when drawing with both types, with fittings and without fittings, we will have the junction box. When it comes to creating schedules, you'll have to pay attention to several things. You see, we can only create schedules of the items that already have been modeled. So if there are any items that you haven't modeled in your plans, naturally you won't be able to create schedules of them. So there can only be schedules created according to the LOD. So when it comes to signing a contract, remember a couple of things, most important of which you need to remember that they don't require a low LOD from you, but then ask for all of the details mentioned in the project. So now we will begin scheduling the ducts. So for scheduling, first we're going to have to go over to the View tab and then find and select Schedules. First you'll have to click to expand its drawer, and then select Schedule/Quantities. After you've done that, this window opens, asking you which categories you want to schedule. So I'm going to go over here to the filter list, then uncheck the items that I don't need. And since I only want to schedule the ducts, I'm going to check mechanical so that we could find the ducts category easier in the list. So by what we've done in the filter list, we can only see the categories that belong in the mechanical. Now we're going to scroll down a bit and select ducts first. You can see that there are some other duct categories like duct fittings, duct insulations, linings, but when it's only ducts alone, it actually includes the straight and the simpler ducts. If we wanted to schedule the fittings, then we would have to select duct fittings, which we're going to get to later. Alright, now I'm going to select ducts, then click OK. Then this next window opens, asking you which parameters of this category that you've selected you want to schedule. On the left side of the window, we can see a long list of all of the parameters that have been used in the project, and those of which that we want to have in our schedule will need to be selected, and then move to the right column which says Scheduled Fields at the top. Let's say that you've gone to a supermarket to shop, and then you'll see so many items on so many shelves, but it's not like you're going to take every single one of them and bring them back home. But you will be picking up the ones that you need and then put them in your shopping cart. So we have the same thing going on here, where we first need to know which parameters of ducts we need to have in our schedule, then move them over here to add to our purchase. Now, what items or parameters do you think we're going to be needing in regards to our ducts? In other words, which parameters about ducts we need to see information of? I'm going to name a few of them, and you can check to see if they align with your guess. The first parameter or field that we need to add to our list is family and type. So I'm going to scroll down over here, it's all alphabetically, then find F, family and type. What do you think this family means when it comes to the straight and regular ducts? And what do you think type means? You see, when we refer to a ducts family, we're actually talking about whether the duct is round, or rectangular, or even oval shaped. So those are the things about ducts families. As for type, it means the fitting types that we use to select for our ducts. For example, radius elbow taps, mitered elbow tees. Those would be the types. So in this schedule, we're going to need to know whether the ducts are round, rectangular, or oval, and their fitting types. This would help a lot with organizing them. So after I've selected it, I'm going to click on this green arrow, which says Move Parameter, which will then move that parameter or field to the right. You see, we also have the individual family field, as well as an individual type field. You could also take those and move them to the right column. Now the next thing, which actually happens to be the second thing that we paid attention to while we were drawing the ducts, is actually the system types. By system types, we refer to whether the duct goes under the exhaust system, or supply, or return, or any other name that we've assigned to them. So for that, I'm going to select the system classification field, then move it to the right, as well as system type. Now, what is system classification? You see, when we were trying to define and add some new system types, we had three main ones at first. They were exhaust, return, and supply. These three are called the system classifications. Now let's say that we've duplicated the supply and then renamed the duplicated one to SAD or FAD. And so these abbreviations that we've put for their names would become the system types. And then the original one, which we've got a duplicate from, would be the system classification. The classification can only be three things: exhaust, return, or supply. Now, is it necessary to have the classification along with the system type? You see, this schedule not only gives us a schedule and a list of information, but it's also a tool for controlling the model. It helps us make sure whether we've actually modeled the items properly or not. For example, let's say that we've mistakenly duplicated the exhaust and then renamed it to SAD. So that would be a problem right there. So if we have the system classification and type together in the schedule, then we could check those details, and if there's any problem, we can go back and correct it. Now, when we were modeling the ducts after the system type, we went to the options bar and entered our size. So in the fields, I'm going to select the size as well and move it to the right column. Now, when it comes to size, there is also this width field. Let's move it to the right. And also the height field, both individually. The size shows the width and height next to each other, which we're going to see later. There is also width and height individually, for in case we needed to have either of them separately. Now, besides those fields, we could also have the length of the straight ducts, so select and move to the right. Now, what's the reason that we've selected the size and the length fields? Or in other words, when we are purchasing the ducts, what exactly do we need? We would in fact be needing the duct foil. That foil then would become the area or the side surface of the duct. And now the question is, do we actually have a parameter for that side surface? The answer is yes. For that, we have the area field. So I'm going to also select that one and move it to the right column. Now, another thing that we could add over here is the reference level field. That one would show that the duct that we have in the list belongs to which level. Is it for the first, second, or the third floor? In case you're trying to schedule the entire project, then you could also sort the ducts by the levels in which they are using the reference level field. So now I'm going to go over here and scroll through the parameters and then select the reference level and move it to the right. Besides this fields tab where we pick the fields and parameters, there are some other more tabs, which are the ones we're going to be working on. But for now, I'm just going to click OK to close this window and see how the schedule turns out. So click OK, and now we've got our schedule, and its columns consist of those fields and parameters that we've selected and moved to these scheduled fields, and under them you can see the value of each instance. So first I'm going to stretch this family and type column a little bit more, and there we go. The first one is rectangular duct, which would be the family, followed by colon, and then the entire name of the type. So basically, the family and type are separated from each other by this colon in the middle. Now, all of the ducts that we've drawn in our bathroom project all belong to the rectangular duct family and type 1W radius elbow / bevel tabs / 30-degree transition. So this is the family and type of all of the ducts that have been drawn in this bathroom project. Now, if we take a look at the system classification, first let me shrink this column. You can see that the system classification of all of them is exhaust air, and their system types are EAD. So after checking, we realized that this one was correct. Now, going to the size column, like I said, it shows the width and height next to each other, with an X between them. So this one's 250 by 250. Also under the width column and the height column, we have the values separately. Then we have the length of that duct, as well as the length of the other instances. And then we also have the area column, which are in square meters. And finally, we have the reference levels, in which they are placed. Alright, now if I click on here and close the schedule, how do you think we should bring the schedule back? Would we have to once again go to the View tab, Schedule, Schedule/Quantities? No, because that way we would start over creating our schedule. So that's not the way to do that. You see over here in the Project Browser palette, I'm going to right-click on this Views Discipline, and then I'm going to select Collapse All, which will basically just collapse all of the open disciplines. Do you see what happens? All of the disciplines have been collapsed. At first, all of the plus signs were expanded, but now they are all collapsed. So I've just done that so that I could see the different parts and the disciplines of the Project Browser palette easily. Now in this palette, we have one discipline that reads Schedule/Quantities. So I'm going to click on the plus sign to expand it. And then I could find the duct schedule that we've just created. And if I double click on it, it'll reopen for us. In this template, there was also another default schedule, which is named Space Outdoor Air Schedule. So let's double click to take a look at it. But you see, since it wasn't set up, it doesn't show any instances, but it does have the columns and fields. And also, if we don't need it, we could just right click on it, select delete, and remove it. Okay, so now we know that all of our ducts were rectangular. Let's go back to the plan. Then go over to the Systems tab, then select the duct command, then select a duct type that goes under the round family. For example, select this one, and also use the system type, supply air, and with diameter 250, and also this default elevation. We're going to try to draw a duct. So click, click, and click. Then I'm going to press the escape key, and now let's go take a look in the schedule. Let's open duct schedule, and if we take a look under family and type, let's stretch it again. You can see that the round duct has also been added to the list. So now we know that if we make any changes to the main model, then the schedule will also automatically update accordingly. So it's not like we have to update or refresh manually. The schedule will automatically update, and that's actually a very good thing and a huge help. Because sometimes we might make changes to our model, and then we won't have to go back and forth between the model and the schedule to update it. And as for the size, we can see their diameters, and obviously since they don't have any width or height, their fields are empty. Now let's head back to the main plan, which is the total plan. And I'm going to try to select all of the ducts in the first level by first hovering on one of them, pressing the tab key once and twice. Once the entire line is highlighted, I'm going to click to select it. And then I'm going to go down here and click on the funnel icon. And I'm going to uncheck flex ducts and air terminals to deselect them. Then click OK. And now I'm going to want to copy these ducts into the second floor. Now up here in the ribbon, we have this copy to clipboard icon. And do you see how paste is disabled next to it? Copy to clipboard. And now paste has been enabled. So I'm going to click on it to open its drawer, and then click on Align to Selected Levels. This is going to paste them in the level that we select, so click. We want to paste the ducts in level 2, and basically they will be copied from the exact location and elevation in which they are, and pasted in the second floor, so click OK. Now let's head back to the schedule. And if you take a look, you can see that the FFL level 2 has also been added. So we could also sort our schedules by their reference levels. So if you go to the View tab, then go to Schedule, Schedule/Quantities, you would be creating a schedule for the entire project and not just a specific single zone. Okay, so this schedule right here is a little too crowded and it might not be very useful. So let's try to reorganize it a little bit and see if we could have a more compressed version. You see, for example, we could either keep the width and height, or since we already have the size which includes both of their values, we could just remove the width and height fields. We're going to be keeping the length, and then we have the area. As for the area value, you see since it has been rounded to a clearer number, it shows only 0 at the moment. It could be 0 point followed by several numbers, but since whatever that number was rounded, it shows 0. We could readjust some settings about this area so that it shows the exact values with their decimal places. Alright, so in the first step, we're going to remove the width and height. And in order to reopen that schedule settings window, we're going to go over to the Properties palette, then click on Edit, which is in front of Fields. So this is actually the first window with which we were adjusting some settings about our schedule. Now we're going to head to the right column and select any field that we want to remove, then click on this red arrow which says Remove Parameter to bring it back to the left column. Same thing for the height, select and remove it. Now in the next step, I'm going to try to sort the schedule a little bit more and try to make it more organized. For example, I'll try to sort the schedule by the reference levels. So for that, I'm going to go over to the Sorting and Grouping tab. Now here I can specify by which parameters or fields I want to sort my schedule. So first I'm going to click in front of Sort By, then select Reference Level, which will then sort and organize the schedule based on the instance's levels. Also, I could have a blank line between each reference level in order to segregate them in their own groups. There's going to be a blank line between each of them. Now let's click OK to go back to our schedule and see how it is. And we can see that the level 1 and level 2 have been separated from each other by this blank line in between. Also, now we can directly edit the Sorting and Grouping tab. And remember that if you click on Edit in front of each one of these tabs, it'll open that same tab. This way you can go directly where you want to readjust the settings. Let's edit Sorting and Grouping. And now that we've sorted the schedule by the reference level, then we will sort them by the system classifications. Also, between each different system classification, we want a blank line so that then we won't mix up the classifications of exhaust with supply or return. For example, let's say that we want to purchase some black foils for the exhaust ducts and galvanized for the supply. That's just one example of where this separation could be useful. Then we're going to sort them by the sizes, as in the sizes will be sorted ascendingly or descendingly, for which we would have to select either of these two options to start from the largest to smallest or vice versa. Now I'm going to go over to the Formatting tab, where I can get a grand total of the values of any field that I choose. For example, we might need the area grand total, so we could have a total of the foil that we will be needing. I'm going to select it, then I'm going to click on here where it says no calculation to open the drawer, then select Calculate Totals, so that then it'll add up all of the area values. We're going to also select the length and calculate totals to have that one's grand total as well. Now let's click OK to see how it turns out. And you see first we chose to have a blank line between each system classification, which we do have right now. And we also sorted them by their sizes, and the order is ascendant from smallest to the largest. And we also have the reference level by which we have already sorted our schedule. Alright, now didn't we want to have the grand total for the length and the area? So where's the grand total number right now? Let's head back to the Sorting and Grouping tab. And you see at first we went to the Formatting tab and decided to calculate totals for those two fields. But we didn't specify where to show it, so let's go to the Sorting and Grouping tab and say that whenever these system classifications are separated, we want to also have a footer, which is almost the same thing as a footnote. Now, what do we want this footer to include? By default, it'll show title, count, and totals. And the title is going to show the title of the classification, count will be the number of the instances, and totals is the adding up the values. Now, if we open the drawer, we can see some other formats that we can choose. For example, we have title, which is the title of that system classification. As in, for example, it's going to say exhaust air. Count, like we just said, is the number of the instances, for example, 14 or 15. And totals will show the addition of the values, either area or length. The second format will only show the title, as in it's going to say supply, exhaust, return, and totals. Then there's count and totals, and finally totals only. So for now I'm going to choose the first format, title, count, and totals. Then click OK. And if we go take a look here, we can see that a new line has been added. But first I'm going to shrink the columns so we can see them better. And as you can see, exhaust air, the instance count is 13. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're sure it's correct. Also, the parameters that we've specified to calculate totals, we can see the totals for here. Now, what if I want the grand totals for all of the instances of ducts in this project? Or for example, what if we want the grand totals for only the ducts in the first level? For example, right now the first level's exhaust and supply ducts are separated, but what if we want their grand total? For that, we once again go to the Sorting and Grouping tab, And if we want the first level's grand total, we're gonna once again go to sort by reference level and also add a footer. Now in that footer, we want to have the totals only, so we're gonna select that format. Also, if we want the entire plan's grand total, here we also have that option, which reads grand totals. Now, just like that footer where we had multiple formats that we could choose, this one also has the title, count, and totals format. Now, what's the title gonna be? Whatever that is written in this field. It says grand total by default, but we could replace it with, for example, total duct. Now let's click OK to see how it turns out. And first we can see that under the reference level, where the first level ends, we can see the ducts total. The total length is 33,890, and the total area is 27. We have the same thing for the second level. We have those parameters totals, and there's also another line at the very end of the schedule, which says total duct and the number of the instances, as well as their total length and their total area. Now here's the thing, we said that we don't see the decimal places for the area values, as in some of them are 0, some are 1. So how can we have their exact values with the decimal places? You see, if we go over to one of our plans, then to the Manage tab, we can find and select Project Units. Now here we can see that the areas unit is square meters. Let's open it. Square meters. And for rounding, we have 0 decimal places. Unit symbols also been assigned for square meter. And first we're gonna click on here to open the drawer and select to see up to 2 or 3 decimal places. If we do that here, then that'll apply to all of the area parameters of the entire project, no matter if it's the schedule or the sheets, which we will get to in the future, or in the modeling space. Now we might not want to do that, and instead decide to keep it with 0 decimal places in the drawing area, but only apply set change to the schedule. In that case, we could go over here and edit formatting, and then select the area field, and this time we're gonna head to the field formatting. So we're gonna click on the button in front of it, which then opens a window similar to that Project Units one. Now here we have Use Project Settings with its box checked, and if we uncheck this Project Settings box, then all of these settings below will be enabled. Now we no longer will be using the project settings. Here we have the units in square meters, we're gonna keep it that way, rounding to 3 decimal places, and we also don't need a symbol, so select none. Also, if there are any zeros at the end of the decimal numbers, we're going to want to suppress or exclude them. Now click OK, and OK. Now the values have changed, and this one was probably 0.340 with its trailing 0 suppressed. But as for the rest of them, we have up to 3 decimal places. So now we've made some changes to the area units only in the schedule, but if we go back to our main plan, then to the Manage tab and select Project Units, we can check to see that the area is still in square meters, rounding still on 0 decimal places, and it also has its square meter symbol. So this is how we can gradually organize our schedules and sort them with more efficient details. Now here's another thing. Under the size column, we have size 200 by 100, 1, 2, 3, 4, 5, 6 instances. In other words, this schedule right here is itemized. It's showing us every single duct instance that we have in this project. Sometimes we might not need an itemized schedule, but require a more compressed and general one. For example, I'm going to want one line for 200 by 100s, followed by a total of their length and areas under the correct columns. This is actually possible to do, so since this itemized schedule is important and is going to be needed, and we might need to come back to, first we're going to head to the project browser palette under the schedule/quantities, then go on to the duct schedule, right click on it, duplicate view, and duplicate it. So now another one has been created with copy 1 at the end of its name, and we're going to need one of them to make the changes. I'm going to rename this one and replace copy 1 with itemized. Remember that by itemized, we are referring to the schedule with the most amount of details. Now let's open this one, which is just duct schedule, where we're going to try to compress the sizes to 1. For that, we're going to have to go over to the Sorting and Grouping tab. So let's click Edit. And you see at the very end of this tab, we have this Itemize Every Instance, which means that it'll show every single instance item by item. Now, if we uncheck this box, then the schedule will be de-itemized. Now let's go click OK. And as you can see, we have 200 by 100 in one single line. Then there's 200 by 150, 200 by 250, then 250 by 250. So now we can see only one instance or line of each item. And as for the length and area values, we've applied Calculate Totals. So that's why now we have the total length and the total area. So now we've got a compressed and more summarized schedule, which is going to be very useful for us.